we are going to differentiate x with respect to t. Sorry. We are going to differentiate 80 squared with respect to t. So this will be the same as the x dt will be the same as 280. So then we differentiate y with respect to t. So it will be y dt be the same as 2a. So from our equation of the chain rule, dy dx equals dy dt times dt dx. Our dy dt for this case is 2a times dt dx. For this case, we are having dx dt. So to get dt dx, it's just the reciprocal times 1 over 2at. So this 2a and this 2a will cancel, and our dy dx will be 1 over t. And for this case, this is the gradient. So to find the equation of the tangent, is changing y or changing x equal to the gradient, and our gradient in this case is 1 over t. So from that point, this is y and this is x. So we shall say y minus 2at all over x minus 80 squared, which is equal to 1 over t. So here we are going to cross multiply. See, you have yt minus 2at squared, which is equal to x times 1, which is x minus 80 squared. When we take this 280 squared to this side, it becomes a positive. You have yt equals x minus 80 squared plus 2at squared. So our yt will be, these values are the same, so a 2 minus a 1 will remain with a positive, which is x plus 80 squared. We need to write our equation.
You are not discussing without what x is.
This case, the equation of the target will be y equals divide.
More SS to share the screen, please. SS screen here, but they're not starting.
All right, we shall now y equals x over t plus at. This will be our equation of the tangent. Without wasting much time, we go to the second part. It says, and write down the equation of the tangent at the point Q, 9a, and minus 6a. For this case, we can use the same gradient, and instead changing y, which is y minus 6a. This is our y, this is our x, all over x minus 9a, which is equal to 1 over t. So this is a plus, we shall have y plus 6a all over x minus 9a, which is equal to 1 over t. So we cross multiply, we shall have yt plus 6at, which is equal to x minus 9a. So when we take this to the other side, we shall have yt, which is equal to x minus 9a. This positive, when the crosses the equal sign, becomes a minus 6a t. And remember, we shall have to write our equation in the form of y equals to mx plus c. So yt over t equals x minus 9 minus 6at all over t. So our equation will be y equals x minus t minus, we can simplify this. We can pull out 3a minus 3a all over t into, so here we shall have 3. Let's see. We shall have 3 plus 2t. Also, minus 680 over t. This is our equation. Sorry.
Okay, thank you so much, student Matuka. Continue.
So our y will be x over t minus 3. We can pull out minus 3a over t into, so be 3, then plus 2t. So this will be our equation. Tangent. Without wasting much time, can I write? We are going to calculate part B. Part B, it says, given the ellipse x squared over 8 plus y squared over 6, which is equal to 1. Then they say find the coordinates of the foci. Then 1 and 2, they want the length of lattice rectangle. All right. So if you are given the ellipse, we have say solution. We are going to compare with the equation of the ellipse. It is x squared over a squared plus y squared over b squared, which is equal to 1. So for this case, according to the question, our x squared is 8. We compare with the question given. So finding the square root, we shall have our 8 as plus or minus 2 root 2. Then our b squared, in this case, is the same as 6. So our minus square root equals root of 6. We shall have our b as plus or minus root of 6. So then we say at the center of the ellipse, the center of the ellipse. The x is equal to 0, y is equal to 0. So the capital X is equal to this small x, and capital Y is equal to this small y. So for this case, we are going to find the coordinates of the foci. It's the foci. For this case, our ellipse is a horizontal ellipse because the A is greater than B. As you can see, this A is greater than this B. If it was, let us say, A less than B, the ellipse would be a vertical ellipse. So for this case, the coordinates of horizontal ellipse is given as AE 0. Then for a vertical, it is 0. We begin with 0, then AE. But for this case, we are dealing with a horizontal ellipse. So the formula is AE, 0. Then you come. What is our A? First deal with the positive side of A, which is positive 2 root 2 times, let us first find E. Then you say from B squared equals A squared into 1 minus E squared. Some of you might wonder where we are getting this formula from. When we were deriving, at the first when we were deriving, here where there is B, there was A squared into 1 minus E squared, close brackets. So we had to let this to be B. That's why from our formula we have B squared. So our B squared is what? For this case is 6, which is equal to our A squared, which is 8, into 1 minus E squared. So we multiply, which is 8 minus 8 E squared. We take this to the other side, becomes a positive 8 E squared, which is, and this 6 comes this side, which becomes a negative 8 minus 6. So remain with 8 E squared equals to 2. We divide through by 8. Remember, we are finding E. Our E squared will be a quarter. So when we are finding E, find the square root of a quarter. And our E will be plus or minus a half. Now we are going to find the coordinates of that foci. Remember what we said was AE, 0. Our A for this case, we first begin with the positive side, 2 root 2 times E, which is a half, 0. These 2 will cancel with this and remain with root 2, 0. This is the first point. Then the other will be negative 2 root 2 times a half, 0. Remain with negative root 2, 0. These are the coordinates of the foci. So, and then they say we find the length of the latus rectum. So the question did not ask for the directrix, but you can find it. Directrix. The formula is x equals to A over E. Unlike the one of the parabola where they say x is equal to negative A, here the directrix, the formula is x equals to A over E. This is for the case of the horizontal ellipse. If it was the vertical ellipse, we would say y equals to A over E. So it will be x equals to, what is our A? Our A is 2 root 2 all over our E, which is a half. So it will be 2 root 2 times 2 over 1, finding the reciprocal. So our x will be 4 root 2. Or our x will be, then we deal with the negative side of a, negative 2 root 2 out of a half, which will be negative 2 root 2 times 2 over 1, which is negative 4 root 2. So in order to find the length of the lattice rectangle, we have got to sketch. So we are going to sketch the ellipse. Our center, remember we said our center is 0, 0. Now we locate where the foci is. We have root 2 and 0. Root 2 is somewhere here. Root 2 and 0. Then negative root 2 and 0. That is the foci. Then we locate where our ellipse is going to and cut from the axis. So you give me the first axis. Remember, from here up to where the ellipse cuts the x-axis, the distance there is a. The distance there is a. Then where it cuts the y-axis, the distance is b. So from the center to where the ellipse cuts the x-axis is a. And what was our a? It was 2 root 2. So 2 root 2 is somewhere here. 2 root 2, then 0. Then this side is minus 2 root 2, 0. Then where it cuts the y-axis, that is b. And our b was here, it will be 0 root 6. Then this side it will be 0 negative root 6. According to the Cartesian plane, this side is a negative, this side positive, positive, and negative. So we sketch. Now we can find the length of the lattice rectangle. So this x-axis is what is called the major axis. So you can find the length of the major axis. And our formula for finding is the length is x1 minus our answer will be 4 root 2 units. So we are going to find the length of the minor axis. Length of minor axis. And for this case, the minor axis is the y-axis. So we say the formula is y1 minus y2 squared, then under a root. And for this case, our y1 is root 6 minus root 6 by square, then under a root. And for this case, our answer will be 2 root 6 units. In other words, find this length of the major axis. You can add from here up to here And then from here up to here, you just get the answers. 2 root 2 plus 2 root 2. You get the length of the major axis. Then from here to 0, it is root 6, but in a negative side. So you can say root 6 plus root 6, and you have 2 root 6, which is the length of the minor axis. For this case, can end here. Success.
Thank you so much, Matuga College, Stelland, for the wonderful presentation. I just request the teacher to just greet us and say what to the candidates. Teacher, Stelland College. So, dear candidates, as we are getting the teacher, one thing I want to encourage you is that whenever we are solving these numbers, do not give out the surds. Leave your answer in that surd form such that you obtain accurate answers. Otherwise, the moment you place your calculator and 2 points, then you are going to be losing out on the accuracy. As teacher of Stelland College, are you on the call? Okay, I think we are losing out on him, but let's have now Colo SS. Everyone on the call, you are going to present Colo SS. Okay. Teacher, you can go on.
I believe we will Teacher Daniel from Stelland College, Matuga. I appreciate you. We have had a presentation from one of our candidates, and as candidates outside there, we always have to give this numbers time, because this one was under geometry. So we are urging you out there that you always give these numbers time, go to your respective teachers, consult them, and then get guidance. That's why you say for the case of the number 32, part B, a candidate has to know that to identify whether you have a vertical ellipse or a horizontal ellipse, you look at the nature of A squared and B squared. Once you discover that A squared is greater than B squared, then you should be able to tell that that is a horizontal ellipse. And then when you look at that B squared is greater than A, or simply A is less than B, you then identify that that is a vertical ellipse before you go on any working. And then you should be able to tell how the foci looks like for the vertical and the horizontal ellipse. Those key points will guide you whenever you're dealing with these numbers of ellipse. I think basically, then the other one for part A, which involves a parabola, it's always the chain rule that guides learners. Once the points are given, like in this format of 80 squared and then the 280, it's always the chain rule that you use to be able to find a gradient. But also you can differentiate. You can get the first derivative of that parabola, and then you substitute in those points for which are given, actually those coordinates for point P,
to be able to get the gradient, so that can still give you the gradient. I believe as we continue sharing, we are still here coming in for paper 2 from Cityland College, Matuga. Thank you so much.
Thank you so much, teacher. Thank you so much for that submission. Okay, Call SS, I want you to take us through analysis. Call. Okay. So they are taking us through number 34, and kindly go on and greet us and we start.
You start. Can you start? You greet them.
Let him be loud.
Be audible, okay? Yes, you greet them.
Okay. Call me Onel Francis from Core SS. I hereby presenting question number 34.
Can you sketch it fast? So, I'm from Core SS. I'm going to take, my name is Ojaf Alfred from Core SS, found in Remote District, northern part of Uganda. I'm going to take question number 34. So the question reads, find the coordinates of A, no, 34. This case, so the curve, see, this is the curve, and so the curve C with the equation y is equal to 14 plus 5x minus x squared, and line L with equation y is equal to x plus 2. So this is the line with equation. This is the line with equation y is equal to x plus 2. And this is the curve. And this is the curve with equation 14 plus 5x minus x squared. So a curve and a line at the point of intersection, they have the same coordinates. So to get the value of our x, we are going to equate this, the value of y. So y x plus 2 is equal to 14 plus 5x minus x squared. So when you take this x, when this process equal sign will become positive. So x squared is equal to x. So x squared, when you take it the other side, will be x positive. So when you bring this 5 the other side, will be negative 4x. So 14 when come this side will become negative. So 14 minus 2 will become negative 12, which is equal to 0. So this is the quadratic equation you can solve using method of factorization or general method. But for me, I'm going to use general formula. So our x is equal to minus b plus or minus root of b squared minus 4ac over 2a. So from here, we are going to substitute the value of x and ac and b. So our value of a is, from here is 1, and then value for b is 4, and then for c is negative 12. So our x is equal to, when we substitute the value for b here, will be positive 4, plus or minus root of our b is 4, negative y squared minus 4 times our a is 1 times c, which is negative 12. So 2 times 1. So when you work out your x, using a calculator, you are going to get so when you work out your x, the first part of x is 6, or x is equal to negative 2. So when you work out the part of x, the first one of x is equal to 6, or x is equal to negative 2. Yeah. So from here, there is a mistake. So this is the root sign, which is over 2a. So from here, after substituting your value for a, b, and c, you are going to get x. The first value for x is 6, and the second value is s is equal to negative 2. So when x is equal to 6, so our y will be, you can either use the equation on the line or the equation on the top, you will get the same answer. So for this one, I'm going to take the equation of the line.
Color SS.
Is, yeah.
Yes, I'm here. Okay, continue.
Okay, so our y will be, when you substitute using the equation of the line, so x plus 2, our y is equal to, when you substitute the value of x here, you have 6 plus 2, therefore our y is equal to 8. So at this point, our x is 6 and our y is 8. So when x is equal to negative 2, when you substitute for the value of x in the equation of the line, you're going to get negative 2 plus 2, where our y will be equal to 0. So at this point, our coordinates are negative 2, 0. So when you check from the drawing here, this side is our negative side, and then this is positive side. So when you drop this one, at this point, mean our x is 6 and our y is 8. So not from there. So our x there is 6 and our y is 8. So at this point, our y is 0 and our x is negative 2. So for that matter, mean our coordinates are going here. It is negative 0. I mean negative 2 and our y is 0. Then at B, our x is 6. Then our y is 8. That is part A. Part A. And then part B is going to take.
Before we leave, call SS. Before we leave, I want you to take us to the formula, the bulldozer. Kindly make it clear the bulldozer method, the formula. I want you to trust the formula down there.
Okay,
that formula. Yes. Okay, yes. Now, don't leave it. Okay, I want you to make it clear that 2a divides the whole formula. Because the way you're writing it, it looks like it is only the square root that is dividing the 2a. So make it clear. And dear candidates, in case you're in an exam and maybe you are forgetting the formula, kindly ask for the logbook. That formula is there in your logbooks such that you can write the right formula. Yes, but still here you have an option of you either using any method of your choice. You feel free to use the factoring method in case it is easy for you. Even the second, put that out of very well. Okay, but the working and everything is very okay. Thank you, Kolo. We can go on to the second part.
So the second part is going to be handled by my colleagues. That is one non-dairy.
Thank you. My name is Juan Derry Kudri. I'll be presenting question number 38. Number 34B, which the first part has been done by my colleagues, as you still see on the board. So I'll be taking over from right now. So before having this, you can let our equation of the line be y1, and we let our equation of the curve be y2. That would help us in the subsequent question, which would help us to find the area enclosed by the curve. So when you look at this curve, so the area enclosed by the curve is given by the integral from lower limit to upper limit of our y with respect to x. But when you look at this diagram, we have equation of the line and equation of the curve. So we have given equation of line y1 and equation of the curve y2. So our equation of the curve is the one which is above the equation of the line. Of course, that is what you need to know when you're handling this area and the curve. There are two things. Okay, there are two scenarios. We have one which is above the other curve, and then one which is below. So the one which is above the curve will actually, we are going to subtract the one which is below from the one which is above the curve. So meaning in this case, when you look at this diagram, we have our y2 being above y1. So meaning we are supposed to subtract the equation y2 minus the equation y1. So here, but our limit enclosed by this curve, as you see from the diagram, we have -2 and 6. So our lower limit is -2. Is -2, and our upper limit will be 6. And our upper limit would be 6. So from here we have our y. So we are going to subtract the equation of the line from the equation of the curve. So we are going to have 14 plus 5x. 14 plus 5x minus x squared, which is the equation of the curve, minus the equation of the line, which is x plus 2. So this one here we are integrating with respect to x. So when you work out this, you are going to come with the integral from -2 to 6 of, so 14 minus 2. So from here we are going to have 12, and then positive 5x minus x, we are going to have plus 4x, and then Yeah, okay, x squared, there is no component here, so we are going to maintain it as x squared with respect to x. So when we integrate using the first law of increasing the power, and of course dividing by the new power, we are going to have integrating our 12x, we are going to have 12, integrating our 12, we are going to have 12x. And when we integrate this one, increasing the power by 1 will give us x squared, and then dividing by the new power, which is 2. Here we are going to have 4 divided by 2, which is 2x squared. And then when we integrate our x squared, increasing the power by 1, we are going to have 3. Then divide by the new power, which would be x cubed over 3. And we are integrating from -2 to 6. Substituting for our upper limit, because this is the area. Substituting for our upper limit, we have 12 open 6 plus 2 open 6 squared minus 6 cubed out of 3 minus our lower limit, which we have it as being -2. If we substitute here, we shall be having 12. Okay, 12 times -2 plus, we have 2, -2 squared, then minus -2 cubed over 3. So if you press this, if you press the first bracket, you are going to obtain we're going to obtain 72 minus so the second bracket will give us -40 out of 3. So if you compute this, we have negative times negative, that will give us a positive. And when you work out 72 plus 40, divide by 3, you will possibly come to 85.3 recurring. Of course, we need to correct to 4 decimal places, and this would be my answer. So here we have it as being square unit. So this is the area enclosed by this curve and the line. So I think I beg to end here. Thank you.
Thank you so much. That is Coral SS for taking us through the presentation. That is very good. That is very good. Thank you so much. Let me first move away. I want to look at something, how you, that is, 2. Okay. Then that is good. Yes, maybe you can show them the second alternative, even when even those, in case you are using the second alternative, you could integrate from -2 to 6, that area, then minus the area of the triangle ABD. That one can as well yield the same answer. Thank you so much. Call SS. Can we have the teacher talk to us? Teacher Call SS, talk to us.
Okay, thank you very much, the organizers. We really appreciate you so much for everything you have done. And we're really so grateful for this. And we request that this program should continue even after this term, probably next term, so that we really prepare our students fully. Thank you very much. I'm here, Francis Opeo, teacher of mathematics and physics from Forest. Thank you.
Okay, thank you so much. Thank you so much. Okay, now next we are going to have St. Mary's Assumpta. Mary Assumpta. Okay, yes, Sam unmute, seems you have, oh. Teacher Sam?
Yeah, thank you, moderator and the presenter. Maybe this is a concern which is not going to Courses only. For those ones who are using camera and the chalkboard, we request that the cameraman or the camera lady try to be stable when taking the video, because it's shaking a lot.
Oh, okay. Okay, thank you so much, Sam. Okay, now we are going to Mary Assumpta.
Good afternoon, everyone. My name is Cecilia, student of St. Mary Assumpta Girls Secondary School. I'm going to present number 38. Our first question is saying that to show that cos 3x is equals to 4 cos 2x minus 3 cos. So this is our question. Now, when we are given cos of 3x, this one here plus cos x plus 2x. So now we are going to apply long-angle formula, which says that cos of x, cos of 2x. Now, cos, since the sign here is positive, we are going to change it to be negative, which will be now sine of x, sine of 2x.
Am I the one who is not seeing the screen?
The screen is clear.
Okay.
Cos of x, which is a double angle. So we are going to expand this cos of 2x, but we are having 3 ways of expanding cos of 2x, which is, but cos of 2x can be written as either 1 minus 2 sine squared x, or 2 cos squared x minus 1, or can be written as cos squared x minus sine squared x. All these 3 formulas can also be for cos of 2x. Now, since our proof is telling us that all what is being proved is in terms of cos, so we shall go with this second formula. So now, instead of using cos of 2x, we shall use 2 cos squared x minus 1. So we shall have cos x into 2 cos squared x minus 1 minus sine x and then sine 2x. If we open our bracket, we shall have 2 cos cube x minus cos squared times negative 1 is cos x. If you multiply cos x times negative 1 will give you negative cos x. We'll have minus sine x. Sine 2x is also a double angle. So now we are going to write it in double angle formula, which can be written as 2 sine x cos x. So instead of having sine 2x, we shall have 2 cos x sine x. Meaning we shall have 2 cos cube x minus cos x minus, if we open this bracket, we shall have 2 cos x sine. Now we're multiplying sine times sine, which will give you sine squared x. We shall have 2 cube x minus cos x minus 2 cos x, and then sine squared x. But we have sine squared x plus cos squared x is equal to 1. So now we want to make this sine squared x the subject, meaning your sine squared x will be 1 minus cos squared x. So we shall put 1 minus cos squared x to replace sine squared x. So we shall have cos 3x is equal to 2 cos cube x minus cos x minus 2 cos x into, now we shall have 1 minus cos squared x. So cos 3x is equal to 2 cos cube x minus cos x minus negative 2 cos x times 1 is negative 2 cos x. Negative 2 cos x minus times negative cos squared x. Negative times negative is equal to, so we shall have 2 cos times cos squared x is cos cube x. So we shall have cos 3x is equal to, now we're going to collect like terms. Here the power is 3, also here the power is 3. So if we add 2 cos cube x plus 2 cos cube x, we shall have 4 cos cube x. Then negative 1 minus negative 2 is negative 3 cos x. B part, it is telling us that hence show that the integral from 0 to 1 out of 6 pi into 4 cos cube x plus 2 cos x dx is equal to 17 out of 6. So now they say that hence show that, meaning we have to start from where we stopped. So our part is saying that the integral from 0 to 1 out of 6 pi 4 cos cube x plus 2 cos x is equal to 17 out of 6. So now from here, from cos of 3x is equal to 4 cos cube x minus 3 cos x. We can decide to make 4 cos cube x the subject, meaning we shall have cos of 3x plus 3 cos x is equal to 4 cos cube x. So we shall substitute this 4 cos cube x here. Meaning we shall have now the integral from 1 out of, the integral from 0 to 1 out of 6 pi. Now, instead of putting 4 positive x, we shall put cos 3x plus 3 cos x. It is added with 2 cos x x. So we shall have integral from 0 to 1 out of 6/5. We shall have, now here, we shall have 3, shall have cos of 3x plus 3 plus 2 is 5, cos of x, x. So now we can decide to separate these things. Meaning we shall have cos of 3x x from 0 to 1 out of 6/5 plus, bring 5 out, 0 to 1 out of 6/5 cos of x x. So now we're going to integrate cos 3x. If we have side work, if we're integrating cos of 3x and x, we can decide to let this angle to be u. We can say that let u is equal to 3x. So meaning here our du is equal to 3 dx, meaning our dx is equal to du out of 3. So here we shall have integral of cos of u, then times our dx is du over 3. So we can bring 1, there is 1 here, so we bring 1 out of 3 out to remain with cos of u du shall have 1 out of 3. If we integrate cos, we shall have sine of u plus c, but the value of u is 3x. So we shall have 1 out of 3 sine 3x plus c. So now here we shall have 1 out of 3 sine 3x is from 0 to 1 out of 6/5 plus. Now we're going to integrate cos of x. Just like from cos of u, if you integrate cos, it will give you sine. So meaning here the integral of cos x is the same as sine x. So we shall have 5 sine x from 0 to 1 out of 6/5. So now we shall have 1 out of 3 sine 3x. We can combine these things. We shall have plus 5 sine x from 0 to 1 out of 6/5. We shall now substitute the upper limit for the value of x. Shall have a third sine of 3 into our x we shall substitute the upper limit, which is 1 out of 6/5 plus 5 sine of 1 out of 6/5. So to be minus, now we shall this time put the lower limit. We shall have 1 out of 3 sine of 3 into 0 plus 5 sine of 1 out of 3. So now this 5 is like 180. So now we shall say 1 times 180 divided by 6. So we shall have 180 divided by 6. It is 30 multiplied by this 3 times 3. It is 90. Then you say sine of 90, which is 1. It is times 1. So we shall have plus 5. Then here you will have 1 times 180 divided by 6. Is 180 divided by 6. You have 30. Then sine of 30. It is a half. Then a half you multiply by 5. It is 5 out of 2. To be minus. Now here we have sign of 3 into 0. It is 3 times 0, then we shall get the sign of 0. If you say sign of 0, your answer is 0. If you multiply 0 times that, it is still 0. And here we shall have 0 plus sign of 0 is 0. To multiply by 5 is 0. So now here we shall put a remaining that plus 1 out plus 5 out of 2. Which is 17 out of 6 as required.
Yes.
Any question?
Well done. I want to know, is there any question? Any school with a question? The father lady. Okay. Yes, teacher Perron. Okay, teacher Sam first come. Yes, teacher Sam.
Yeah, I just want to appreciate the good work of the lady. Thank you so much for the wonderful presentation.
Okay. Yes, teacher Perron, come in. There is something you wanted to share.
Okay, thank you, sir. I thank the presenter for the wonderful presentation that she had. But instead of writing the pi as 1/8, if that person puts the calculator in radians, then I think that person can easily get the answer minus putting the 1/8 and whatsoever. And that's my submission, sir.
Okay, thank you so much. That is true. Even when your calc is in radians, it will work. The only challenge is forgetting to take it back out of radians. Okay, that is wonderful. In case you have any questions, can we have the teacher St. Mary's Assumpta? Because your camera was really very stable, kindly talk to us.
Thank you very much, Mr. Yeah, I'm called Mr. Mtunch Karen. I'm the mathematics teacher. Maybe something I would like to say about trigonometry. Learners have to be careful, especially when they are doing trigonometry. They have to be closer to mathematical tables because most of these identities are there. And more so, it needs more practice. That's what I would like to say. Otherwise, thank you for the arrangement. How I wish this one could be done also for the seat for you. Thank you very much.
Okay, thank you so much. Thank you so much, dear ladies of St. Mary's Assumpta. Your presentation was okay. Teacher, you'll take for us a photo of those girls during their listening in. I want now to listen in from Sacred Heart. Sacred Heart. Yes, and the cameraman was really very nice. Okay, thank you. Sacred Heart, kindly, we want you now on board. Have your Sacred Heart talk to us. Sacred Heart, are we failing to get you? Talk to us. Your microphone is. Sacred Heart, talk. We want to first hear you. Okay. Yes, teacher. Maybe increase on your volume. Sacred Heart. Are you hearing us? Because I'm not hearing you. increase maybe on your volume. We are not hearing anything. We are not hearing anything. We are not hearing anything.
Moderator, we are not hearing Sacred Heart, please.
Now we are hearing you. Oh, was that Sacred Heart? No, that was Mr. Sam.
No, this is Sam.
Oh, okay.
I'm not hearing Sacred Heart.
Yes, that's what I'm telling them. Sacred Heart, for you, are you hearing us? Okay, Sacred Heart. No, we are failing to get Sacred Heart. Okay, they are trying their best, though we are failing to get them. Let me ask then, there is St. Joseph's College, Gulu. Sacred Heart, let's first be trying. Try, you are going to come back. I want to hear from St. Joseph's College, Gulu. Okay, I'm also not getting St. Joseph's College. Can we hear from, okay, you try, BISS. BISS. Dijuman. BISS Dijuman. BISS Dijuman. You said you are ready. BIA unmute. Oh, I'm failing to get them. I'm going to call another school. Sacred Heart, try, because I want to hear from Sacred Heart. You talk, first talk, and we see whether we can hear you. Sacred Heart, first talk. No, we are not getting your volume. We are not getting your volume. First unmute again. Timothy, could you think we can have a solution? Okay. Sacred Heart, can you check the volume of the laptop, something like that? Okay, I'm failing. We are failing to get you. Your volume is not on. Your volume is not on. Something is wrong. Okay, I want to hear Biaya, St. Catherine, are we ready? We can. St. Catherine, okay. St. Catherine is also not ready. Okay, St. Catherine leader, are we ready? Okay, St. Catherine is not on board, so we are going to go back and I'm going to ask St. Joseph's College or Batch to be the first. Then we shall go back to Kakila. Then we shall go to St. Mary's Assumpta. St. Joseph's College. St. Joseph's College.
Hello, everyone. My name is Asiku Collins from St. Joseph's College, Mombasa. I'm going to take you through question number 35 from Pure Maths. Question number 35, part A says that given that y is equals to cot inverse of x, so that y x is equals to negative 1 over x squared plus 1. It says that
Let's remove this. Get back.
Sacred Heart, you are ready. We will discuss after St. Joseph's College. We can hear now your mic.
Okay, fine. Okay.
y is equal to cot inverse of x, so that dy dx is equal to negative 1 over x plus 1. From here, what we are going to do is, first of all, this expression is same as cot y is equal to x. From this now, from trigonometry, you know that. Let me put my side note here. Cot square y plus
the
1.
presenter, I kindly be at the side. Be at the side.
Cot square y plus 1 is same as cosec cot square y plus 1 is same as cosec square y. Okay, then from here, what we are going to do is we shall differentiate both sides, left hand side and right hand side. Okay, when we differentiate this one, related to x, okay, first of all, cot y is same as the inverse of tan. Mean also from trig. Tan y is same as sin y over cos y. Okay. Also, cot y is same as inverse of tan y, which is same as now cos y over sin y. Then from here now, when you say this one, you are going to get 1. Then for the case of this, we are going to use cosine rule, where this is same as cos y over
Chibingo girls.
Now we are expecting
negative sin y. Also, the denominator is same as sin y. dv dy is same as cos y. Then from here now, from cosine rule, du. This time we're not going to use, sometimes you may find someone using now X here, but from here we're going to use Y. Minus dv dy over d square. Okay. Here our value v is sin y. Du dy is now negative sin y. Negative sin y minus the value of u is cos y. The value of the v dy is cos y.
Not seeing, we are not seeing.
Okay. Cos y over d squared is now sin squared y.
We are not seeing what you are presenting, please. We are not seeing.
Okay. Then from here, this is same as negative sin squared y minus cos squared y over which is equal to 1. Okay. What? Yes. What? Yes. Then from here we can factor out -1 from this expression. When we factor out, here we shall be having sin squared y plus cos squared y over sin squared y equals 1. Then from here, from trigonometry, sin squared y plus cos squared y is same as 1. Then from here now, our value of y dx is now -1 over sin squared y is equals to 1. But in the side, first of all, my side goes somewhere. Inverse of sin y is same as cosec y. That means the inverse of now sin squared y is the same as negative cosec squared y. When you substitute it here now. Okay, from here, from our geometric identity, cot squared y plus 1 is same as cot squared y plus 1 is same as cosec squared y. Then from here, if from here, our expression with this one, mean from here now, where there is cosec squared y, we're going to substitute this expression. 1 plus a 1 plus a cot squared y. Then from here, our value y dx will be negative cot squared y plus 1 is equals to 1. Okay. From our question, first of all, let us first get rid of this negative. Mean y dx, when we divide this expression into a negative, then we shall be left with cot squared y plus 1 negative 1. From our previous expression, our value of cot from, let me say from y is equals to cot inverse of x. Mean, well, for us to get the value of x, mean our x is the same as cot of y. Where there is cot of y, mean we are going to substitute x. Then from here now, our value of y dx is it x, it's now x squared plus 1 is equal to negative 1. From here now, we can make y dx a subject by dividing through x squared plus 1, mean our value dy dx is now therefore our value of dy dx is negative 1 x squared plus 1 as required from the question.
Okay, thank you so much. I want to just find out whether there is any person with a question. But I want to first ask Mr. Sam before he leaves, because he has been doing a great job. Mr. Sam, kindly introduce yourself and give a word to the candidates. before we call on Colo SS. Okay, Colo SS, we are going to call on you. I want Mr. Sam to say something.
Okay. Let us go to
a minute. I want Mr. Sam.
Yeah, thank you, presenter. Moderator, but maybe for protocol. My name is Odong Samuel Tochon. I've been teaching now for the last 25 years. I've been teaching physics and mathematics at O level and at A level. Currently, I'm lecturing at Sutema University in the faculty of engineering, but I enjoy mathematics and physics. I would like to encourage candidates that the initiative that has been brought on board is the way to go. Presentation has been one to try to bring students more. You cannot read mathematics. Your presenter have to appreciate every step together, always, whenever this kind of activities are taking place. Thank you so much.
Okay, thank you so much, Teacher Sam. We really appreciate your service. I think we need to get in connection such that we build this kind of engagement, and maybe one time we shall even have you talk to these candidates. So Mr. Sam, let me send you something in the WhatsApp chat such that we can talk further from here.
Thank you so much.
Thank you so much. I'm going to ask the presenter, St. Joseph, a minute. Yes, call SS, kindly ask your question.
And then one more day from call SS, and I'm having this. You know, as 6 students, we normally buy time in examination. So instead of all those steps, there were there was a simple steps that the candidate could actually use instead of all that long step, because in the examination, we are timed and in accordance to our step. So instead of going all through the step, after differentiating and getting our differential product of y equals to x, that one will give us negative cos x squared y dy by the s equals to 1. So from there we can divide all through by negative cos x squared y and try to get the identity from cos squared x plus sine squared.
Okay, we have lost him. Thank you. We have lost Colo SS. I'm going to ask Colo SS. They are going to write for us the second alternative, and then you are going to share with us, because after this activity, we are going to be coming up with a solution. I'm going to ask St. Joseph's College Obachi to summarize for us that part. Mainly, if you have the solutions already, I want you to just give us the hint. For now, we can do part B and part C, because we want also Sacred Heart to say something. We want St. Catherine. Okay.
Okay. From now, from part B, I'm going to give you hint of paper 2. You say that express 6 x squared minus 10x minus 9 over 2x plus 3 x squared plus 1. Okay, first of all, if you observe this, if this expression, this is the form of partial fraction. First of all, you first check the order of the power. Whether it is a proper fraction or improper fraction. You check it by this. The order of this expression is the power 2. Mean from here now, if you open this bracket, mean the order will be the power 3, mean that is the proper fraction. Then from that, after knowing that it is proper fraction, then you will say that this expression, this I mean equivalent to, this expression is equivalent to, mean first of all you check from here. You check the orders. From here, if you see this expression, this is linear. This is linear. Then the expression is quadratic.
Saint Joseph, your microphone is off. Have your microphone on.
Okay, from here, let us use B. Since this one is quadratic, we shall put our x here, x plus another constant over x squared plus 1. Reaching up, after reaching this one now, we can get the addition of this one.
These are those which is equal to all x squared into power x. And
okay, from here now, 2x plus 3, x plus 1, x minus 9 is equivalent to, then the LCM. The LCM of this one is 2x plus 3 times x squared plus 1. Okay, when you divide this one by this, when you are going to get here, x squared plus 1 plus dx plus c. You need to put bracket here. So, okay, from here now, this is it, times 2x plus 3. Then, after reaching this expression now, this is equivalent sign. You cannot neglect it by. Okay, first of all, when we put this one, automatically this one will cross.
and then that.
Okay, from here now, 6x squared minus 10x minus 9. The same was if you open this bracket, this is x squared plus f plus dx times 2x, we shall get 2x squared b. This times this, we shall get this and this, shall get 3x plus this and this 2x c plus this and this 3c. Okay. Then from here now, we're going to collect. We are going to collect the like terms. 6x squared minus 10x minus 9 is same as if you collect this one. A plus 2b x squared plus 3b plus 2c.
St. Joseph. Okay, you first collect on number 1, that is a plus. A out of 2x plus 3. Check out that as if you wrote a minus. The first step. No, the first step up. That is 2x plus 3. You wrote it like a minus. Okay, continue.
Then from here, A plus 3c. You're going to compare the coefficient from left hand side and right hand side. From here now, we compare x squared with the x squared. If we compare it, a plus 2b is same as 6. So first equation 2b 3b plus 2c is equals to negative 10. This is our second equation. A plus 3c is equals to negative 2. This is our third equation. Then from there, you can see from here, we can eliminate A by subtracting equation 2 from A. Equation 1 minus equation 3. When we subtract this by A minus A, we shall get nil, that is 0. Then from here, 2b minus 2b minus 3c is equals to 6 minus 9. When this one is equals to, we shall get 15. This is our fourth equation. When we shall now to get the value of b, we shall use second equation. Then from here, second equation 2b minus 3c is equal to 15. Then from here, J P minus plus 2C is equal to negative 10. Okay, from here, for us to eliminate B, mean we shall multiply this one with 2 and the other one with 3. If you multiply this one, this and this is 6. 6 minus this and this. This and this is 6. P minus 9C is equals to 45. This and this 6. Six B this and this plus 4 C and when we subtract this, here's nil. When you subtract this, negative 9 minus positive 4, so I get negative 13. If we subtract 45 minus 20, we shall get 65. Then from there, we shall divide it by negative 13. All we will see is negative 5. Okay. We shall use the fourth. We shall use the fourth equation to get the value of C. 2B minus 3C is equal to 15. We know what we'll see. 2B minus 3 times negative 5 is equal to 15. Means 2, if you multiply this negative, so get positive plus. Mean from here, if you take this on the other side, mean 2B 0. Then from here over will be 0. Okay. Let us get the value. Let us get the value of F from F plus 3C is equal to negative 9. We know value of C. C is negative 5. Mean F plus 3 times negative 5 is negative 9. Mean our value of F is now negative 9. F minus 15 is equal to negative 9. If you take negative 15 to the other side, you change the positive. Our value of F will be negative 9 plus 15. Our value of A is 6. Okay, from 6x squared minus 10x minus 9 over 2x plus x squared plus 1 mean that's a over 3x plus 3 plus x plus c below the value, now we can substitute the value of a, b, and c. X plus 3 our value of a is 6. Plus our value of b was negative 0. Mean if negative 0, our value of b was 0. If multiply 0 by x, this will be 0. Our value of c was negative 5. Mean okay, from here on, 6 over 2x plus 3. The whole of this one will be around 0. This one will be negative. Oh, media. X squared plus 1.
Okay. Thank you so much, St. Joseph's College Obachi. I understand there is part C, but I'm going to request all schools that we shall try out part C. Good enough. Now the number is really very simplified, but I want the teacher to first talk to us, St. Joseph's College Obachi. And in case there is any person with a question, okay, after the teacher, I will have teacher Perron talk to us.
Good afternoon, everyone. My name is Mario Nelson, the teacher of Maths 1. I'm so grateful for this organization. Maybe my message to candidates is that when you encounter questions to do with partial fractions, it is always necessary to determine the nature of that fraction before you move to other steps. Because when you fail to distinguish the type of fractions given, which means there you are likely to make mistakes. So it is advisable to change from improper to proper, where you realize that it is improper fraction. Because you know usually here we work based on proper fractions. I think that's all what I can tell them. Then concerning the integration parts, there it is just all about application of the concepts of integration. Thank you.
Thank you so much, teacher, for preparing the learners. Teacher Perron.
Yes, sir.
Okay.
My submission is, I first thank that person who was presenting, but may have a simple way of solving for those values of A, B, C. Like for example, as after he has got the expression, after removing the denominator, then he can use the cover-up method so that he easily gets the values of those constants. For example, when let's say when he substitutes for x equaling to -3 out of 2, then that one, when is substituted for the other bx plus c into that 2 times -3 out of 2, then it will cancel the b and c and will remain with a, and then he gets the value of a. And he can use maybe 0 for the second time, he eliminates b and gets the value of c since he already has that of a, and finally can put like 1 for x and get the value of c. That's my submission, sir.
Thank you so much. Okay, thank you so much, St. Joseph's College, Obach, for that wonderful presentation. Can we have now Sacred Heart present? But I'm going to ask St. John to get ready after Sacred Heart. Then we shall also have St. Catherine. Okay, yes, Sacred Heart. Sacred Heart.
Yes, hello.
Yes, you are clear.
Oh, yes, we're here.
Good afternoon, everyone. This is Sacred. My name is Akim Patricia from Secretariat Secondary School, Gulu. We are presenting number 14 under vectors, and the question reads: find the Cartesian equation of the line of intersection of the two planes. So the first equation of the plane is 2x.
Excuse me.
Sorry for that. The first line of the equation, the first equation of the plane is 2x minus 3y minus 6 equals to 1. And then the second equation is 4y plus 3x plus 2z equals to 3. So we are asked to find the Cartesian equation of this, the Cartesian equation of the line of intersection of the plane. So we are going to name our equation as I made mention. This is equation 1. And then for equation 2, as you see, it is starting from 4y plus 3x plus 2. So we are going to rearrange this equation to make it 3x plus 4y plus 2z equals to 3. So this is going to be our equation 2. To find the Cartesian equation, the first thing you are going to do is you're going to solve these two equations simultaneously, of which you're going to check 2x minus 3y minus 2 minus z, is equals to 1, and then 3x plus 4y
Are we losing on Sacred Heart?
4x minus 6y minus 2z equals to 2. And then this will be negative 3x minus 4y minus 2z equals to negative 3. So you're going to subtract these two equations in order to eliminate z. So if you're to subtract 4x minus negative 3x, you're going to get 4x.
Sacred Heart, unmute.
So this is negative 6y minus negative 4y, which will give us negative 10y. Minus 2, sorry, negative 2y. Then negative 2y, negative 2z minus negative 2z, which is 0. And then 3 minus negative, 2 minus negative 3 is 5. Sorry for this, just a problem of space. So we have 7x minus 2y equals to 5. This will now be our equation star for having eliminated z. So from here, we are going to make either x or y a constant. And I'm going to say let. So here we are going to make x, let x be equals to lambda. So if our x is equals to lambda, we are going to start like if the x is already equals to lambda. So where there is x, we are going to put lambda. So 7 into lambda minus 2y equals to 5. So 7 lambda minus 2y is equals to 5. We want to get y in this equation. So we are going to take 7 lambda, the other side, to get y as y alone. So this will be y will be equals to, this is 5 minus 7 lambda divided by negative 2. Hope we are done with here. So we have y equals to 5 minus 7 lambda divided by negative 2. But we can do away with this negative 2 and make it y equals to, if you divide like the whole thing by negative 1, it will now be 7 lambda minus 5 out of 2. Since we now have x in terms of lambda and y in terms of lambda, we are left with getting z in terms of lambda. So we are going to take either equation 1 or 2, but for my case, I'll take equation 1. So we are going to substitute. We are going to substitute for x. We are going to substitute x and y in equation 1. In equation 1 to get the value of z. And our equation 1 is 2x minus 3y minus z equals to 1. So since we have our x as lambda, so it is 2 lambda minus 3 into our y in terms of lambda is 7 lambda minus 5 out of 2 minus z. It's still not yet there in terms of lambda, so it's what we are going to find. Equals to 1. So this is 2 lambda. Wait. So this is 2. We are going to multiply this 2 by all so that we do away with it. So it is going to be 4 lambda minus 3 into 7 lambda minus 5 minus 2z is equals to 2. So from here, we are going to open these brackets. I'll have to wrap again here. So this would be 4 lambda minus 3 times 7 is 21. Four lambda minus 21 lambda minus 15. Sorry, plus Yeah, because we are multiplying -3 and then -5 gives you a positive 15. Minus 2z is equals to 2. So 4 minus 21 is going to be -17. -17 lambda minus 2z is equals to, we are checking this 15 the other side. So it is going to be now 15 minus 2, which is -13. Remember, we are looking for z as z, not as 2z. So this is going to be -2z equals to -13. This is going the other side, so it is becoming a positive 17 lambda. So our z here would be equals to 13 minus 17 lambda out of 2. I hope you understand how this came about. I've divided this by -2, so the negative, if you should divide all of this by negative, this negative will cancel, and then a negative will come with 17, making it a -17 number. So this is our z value. Then from the equation, from the Cartesian equation, equation formula, we have R is equals to F, which is the position. F, which is the position vector. According to the vector equation. This is according to the vector equation, where this R is expressed. Now we write here again. So this now will be in form of X, Y, and Z. Will be equals to our A will be our F for the X. Remember, our X is equals to lambda, and then our Y is equals to 7 lambda minus 5 over 2. And then this is for our Z. So our F from here for the X is going to be equals to 0. And then for the Y is going to be equals to -5 out of 2. And then for the Z is going to be 13 out of 2. Plus, we have our lambda. If you are to bring our lambda out, we are going to remain with, for X is going to be 1. For Y is going to be 7 out of 2. And then for Z is going to be -17 out of 2. But we cannot leave it in this way, so we are going to write it as X, Y, Z is equals to, but to pull 1 out of 2 out, we are going to have here 0. It will be -5, and then this will now be 13 plus. This will be lambda out of 2 into this. If you have to make lambda out of 2, then this will be 2. For X will be 2. For Y will be 7. And then for Z will be -17. Then we are going to, like, to make it a bit easy to be written in a parametric way, we are going to let lambda out of 2 be equals to so since now lambda out of 2 is equals to mu, our equation will be X, Y, Z is equals to 1/2 into 0, negative 5, 13, plus this will now be mu, it will no longer be lambda. This will be 7, 17. So we have, since we now have it in this form, we are going to say x is equals to 0 plus 2 mu, y is equals to negative 5 out of 2 plus 7 mu, z is equals to 13 out of 2 plus 17 mu. So from here, we are going to make mu the subject in each of the following equations. So for x equals to 0 plus 2 mu, our mu will be okay. So x is equals to 0 plus 2 mu. Our mu equals to x over 2. Then for y equals to negative 5 out of 2 plus 7 mu. This will go this side and it will become a positive. So it will be y plus 5 out of 2. Sorry. 2y. So this will be 2y equals to negative 5 plus 14 mu. So this will be 2y plus 5 equals to 14 mu. Our mu will be equals to 2y plus 5 out of 14. Then we are going to the last part, equals 13 out of 2 plus 17 mu. Sorry. This is 2z equals to 13 plus 17 times. This is 34 mu. Then this will come this side to become a negative. This is 2z minus 13 equals to 34 mu. So mu here for this case it will be z. Sorry, this will be 2z minus 13 out of 34. So since all these have been expressed in terms of mu, that means our final answer is going to be for the value of x. For the first mu, it is going to be x out of 2 equals to, we come for y, this is 2y plus 5 plus 5 out of 14 equals to 2z minus 13 out of 34. So therefore, so now the Cartesian equation of the line of intersection, if two planes intersect, they form a line. So the Cartesian equation of the line is 2x, is x out of 2 equals to 2y plus 5 out of 14 equals to 2z minus 13 out of 34. Then we'll go to the B part of the question. The part B of the question is saying vectors A, B, and C form three sides of a triangle. Given that the A is 5, magnitude of B is 12, and then A dot B is 30 root of 3. Find the area of a triangle. So if we are finding the area of a triangle using vectors, we should know that in the definition of dot product, A dot B gives us a magnitude of F, magnitude of B, cos of the angle theta. This is the angle formed like when these two lines meet under vectors. So now this is, if this is our triangle, this is A, B, and C. This is our A, B, C, whereby the A has been given as 5, and then B. So we are going to get the angle between the angle between these two lines. So A dot B has already been given as 30 root of 3 equals. This has already been given as 5 times 12 cos of the angle theta. So it is 30 root of 3, 60 cos of theta. So our theta is going to be the cos inverse of root of 3 out of 2, because this 60 is coming here and it's dividing this. So you'll be left with a half. So theta from here is going to be 30 degrees. So since now you have the angle, that means you can get the area of the triangle as asking a question. The area of the triangle according to vectors, sorry. The area of the triangle according to trigonometry area is equals to a half A B sine C. So now we are getting the angle C, which is the angle required. We have finished getting the angle C, which is 30 degrees. So now we are just going to substitute in order to get the area of a triangle as required. Area is going to be a half times 5 times 12 sine of 30 degrees. So this is going to be a half times 60 sine of 30, which is 30 sine of 30. And if you press in your calculator, the area is going to be 15 square units. You cannot write centimeters because it has not given us, it has not been given whether in terms of centimeters or so we leave the area at 15 square units. Thank you. That was a presentation from Secretary.
Thank you so much, Sacred Heart, for the wonderful presentation. Hope I still remember this is Patience. True?
Team Patricia.
Patricia, okay. Thank you so much, Patricia, for the wonderful presentation. Can we have the teacher talk to us?
Thank you, Mr. Zimba Steven. And your team, I am called Daniel Komboni, teacher of mathematics at Secretary. We are really very grateful for the initiative of having the learners across the country to appreciate the knowledge of math and use it very well. By this, I would just advise the candidates, more especially those attending the program, today's program. I know time may not be enough to explore all the questions you had sent for us, but they should find time, of course, together with their teachers and sit and explore more. I believe it will have a great change in them. We thank you so much. We will be looking forward to other programs from you. Thank you so much.
Thank you so much, Sacred Heart. Can we now go to St. John? St. John Post-Secondary, kindly unmute. Then after we shall go to St. Catherine and then Biaya.
Yeah, we still have.
Okay. Yes, St. John, kindly go on. St. John, I want to see your video. Where are you?
That's the presentation.
St. John, which screen are you using? St. John, take us to your presentation. Let's give them a minute as they get ready. St. John, we want to see your yes. Can we have a school that has a paper to number? Kindly send in the chat the number. If John Paul Secondary School, we are waiting for you. John Paul, we are waiting for you to take us to your board. Which other screen are you using?
Hello.
Yes, please. We can start.
We are presenting number 21 on 3.
Are you able to hear me?
Yes.
Are you able to hear me?
Yes, you are clear.
Yeah, Try Joseph. In JPSS Palisa PO Box 110 Palisa. Now we have a number here. I have a number here to present to the rest of the listeners. This number 21, I think everyone has a question paper. It goes, it's given that the angle theta satisfies the equation. Yeah. You divided the screen, divide it. Yeah, this is our equation. Our angle theta satisfies this equation. They are saying if it is satisfied, show that tan into theta is equal to a half. We are to show that
Right, big.
tan into theta equals to a half. Now, with our knowledge of 3, this angle is the same as this angle. There's one angle. Somebody else can also expand this. Somebody can try say divide both sides because of this angle. This angle is the same. But for me, I choose to divide by this angle. I divide both sides by cos 2 theta plus a quarter by, let me say, sine of 2 theta plus a quarter pi equals to 3. Cos of 2 theta plus a quarter pi. Multiply both sides by cos 2 theta plus a quarter pi. This one angle divided by cos 2 theta plus a quarter pi. Here, sine plus cos, it's the same angle. I can get what? Tan of 2 theta plus a quarter
pi. Here I get only 3.
Mr. Kaziba. Mr. Kaziba?
Yes, Mr. Ronald.
We are back in the main room. Can you move these ones to the main room so that John Paul completes from the main room and we close? It's 4:12, it's 2:30.
Okay.
And the people here leave the room and come to the main room and John Paul Secondary School completes from there.
Okay, okay.
Members,
we can expand this.
the camera is shaking.
This is the same as tan of 2 theta plus tan of a quarter pi over 1 minus tan theta tan a quarter by pi equals to 0. But what I know, but tan a quarter of pi is the same as, in degrees, is the same as 1/8 divided by 4, which is 45. In terms of radians, we take it as pi by 4, which gives us just what? A half. That's 1. It gives us 1. We get tan of pi by 4, we get 1. Now I want to substitute this 1 into our equation. We shall have tan 2 theta plus 1 over 1 minus tan of these 2, there's some 2 here, sorry. Tan 2 theta, we multiply all this by 1 equals to 3. Now, at the same time, I want us to cross multiply. We shall have tan 2 theta plus 1 over 1 minus, okay. And first put this tan 2 theta equals to 3. I cross multiply. I will have tan of 2 theta plus 1 equals to 3 into 1 minus tan of 2 theta. We have that. Now, I want to open this bracket. I will have, we shall now have tan of 2 theta equals to 3. Let's assume this one has also crossed here. Okay, sorry. We can put it also here first of all, plus 1 equals to 3 minus 3 tan of 2 theta. Let's collect like terms. This one crosses this way, and this one crosses the other side. We have tan of theta minus 3 tan 2 theta. When this one crosses equal signs, it becomes a positive. So when it crosses equal sign, we shall have tan of 2 theta plus 3 tan of 2 theta equals to, this one crosses equal signs, 3 minus 1 becomes a negative. These ones are just the like term. We can add 1 plus, we shall have 3 minus 1 equals to 2. We can choose to divide both sides by 4. Divide both sides by 4. We shall have 4 and 4 cancelling. We have tan 2 theta equals to 2 by 4. Tan 2 theta equals to, reduced by 2, 1 by 2. We shall have 1 over what? 1 over 2 as required. This was what we required to show. That is the end of part 1 of our question.
Okay, St. John Paul, I'm going to kindly request you that we are going to end at that part. Then I'll ask schools to try other number. Mr. Ronald? I've sent you some message. I wanted us to do just more two, one for mechanics and one for statistics, and we'll cross.
Okay.
Okay.
Bye.
Yes, Mr. Ronald?
Okay. Members are still here. That is okay.
Okay. St. Joseph and Matuga. Mary Assumpta. Mary Assumpta, take us through that. And Matuga. Mary Assumpta and Matuga. I want one for mechanics. Mary Assumpta. Okay. Matuga, are we ready? Sorry, Assumpta, okay. Okay, we can start. Matuga, sorry, Assumpta.
Ask them to unmute. They are muted.
Assumpta, unmute. Okay.
The question reads, are these questions random? Good afternoon, members. I'm called Ayuro Sharon, a student of St. Mary's Assumpta class. We are coming to discuss question number 88. This random variable has the following PGMs. Here is the function. The first part of it is saying that we should find the value of P and N. As we are seeing here that it's a discrete random variable. This is the general function. It is for all value of X. Probability of X is equal to X. Then we equate it to 1. Then we shall have if X is equal to 1 plus X is equal to 2 plus X is equal to 3 plus up to X is equal to N. Then we equate it to 1. Now from here, the function given for us is here. Like from here, our value of X is 1. So here we shall have P plus 2P plus 3P plus Pn is equals to 1. Here we have common if we can see we are having this P is in common, so we shall remove it out and have 1 plus 2 plus 3 plus n is equals to 1. Like if you see what is in the bracket, it is in terms of series. It is like 1 is equals to 1, we are adding 1, 1. So from here we can get this function in the logbook. Page 58. Like this. R is equals to n into n plus 1 over 2. This formula, we shall only put it for what is in the bracket. So our P will be now n into n plus 1 over 2 over 3 is equals to 1. If we see here, we can bring our 2 here. So we shall have Pn into n plus 1. Now here, the equation 1. So from here, we can draw our table, our x, the probability of x, the probability of x is our x, they gave us it starting from 1, 2, 3. Out here, our P, our x is 1. So here we shall have P, here 2P, 3P, and P. For this one, now we shall multiply this and this to give us this. So we shall have 4P. We shall have P, 4P, 9P. Here we shall have n squared P. The value of the expectation of x is 7. In this column, if you add this one, it must give you the expectation. So for this, we are coming to add this and equate it to 7. We shall have P plus 4P plus 9P plus up to n squared, and then we equate it to 7. Now we shall pull out the common factor. We shall have 1 plus 4 plus 9 n squared is equals to 7. If you see here, our n is in square, and all these ones we can express the square. So here we shall have 1 plus 2 squared plus 3 squared plus n squared is equals to 7. For this one also, we can get the formula in the logbook, also in the same page. The formula is here. N into n plus 1 to n plus 1 over 6. So we shall express the whole of what is in the bracket for this. So here we shall have P into n plus 1, 2n plus 1 over 6 equals to 7. Here we shall have Pn into n plus 1, 2n plus 1. Then we bring this one inside. It will be 42. Now we shall solve this equation to get our value of P and N. So for this, we shall take this value. We shall substitute equation 1 with equation 2. Now we shall put equation 1 in equation 2. As we can see, the order of this is this and this 2. So there we shall put 2 n plus 1 is equals to 42. So we shall have 4n plus 2 is equals to 42. Here our 4n will equals to 40, then our n is 10. We can put this value of n in equation 1 to get our value of p. So from equation 1, n plus 1 is equals to 2. We shall put our 10 into 10 plus 1 is equals to 2. If we add this, we get 11 times 10. We shall have 110p is equals to 2. Our p is 1 over 55. Our new function will be one over 55 x is equals to 1, 2. Up to 10. So we are done with the Roman number 1. Now we are coming to Roman number 2, where they are telling us to find the probability of 2 is less. So they are telling us to get this probability. Here now we can express it as now we can express this probability as this intersection x is greater or equal to 4 over the probability of x is greater than or equals to 4. So we shall simplify this as p as probability of 2 is less x less than 7 out of probability of x is greater or equals to 4. From here, they are telling us that the probability of this is lying between 2 and 7. So here we shall not include the probability of 2 and 7. We shall only include the one for 3. So we shall have probability of x is equals to 3. Probability of x is equals to 4 plus probability of x is equals to 5. X is equals to 6. Over. Here we shall start from 4 because they are telling us that it is x is lying where it is greater or equals to, it means we shall start from 4 up to 10.
Mary Assumpta. Mary Assumpta.
Yes.
Kindly first check out the 2 less than x less than 7 intersection x greater or equal to 4.
Our 4 here it is inside 7, so we cannot put it. That's why I've only included the 2 and 7. So from here, we shall base ourselves on this way, on this function. Here, our x is 3. So there we shall have
Mary Assumpta. Mary Assumpta, can we draw that on a number line? Put it on a number line. Just draw a number line and show us those 2 sets. The first set is starting from 2 to 7. Okay, you show from 2 to 7.
Here is 2, and our 7 is here.
You show, draw.
Here, it is 2 to 7. And from the question, they are telling us that it is lying between those numbers. They did not tell us that it is lying between x. They did not tell us that it is this or this. If they were to include this symbol, then you are going to include the 2 and 7. I left the 2 and 7 because they did not tell us that it is lying between.
Okay, now show us from 4. Show us the second set.
From 4.
So where is the intersection of those 2? Where is the intersection of those 2? Shade it, shade the intersection. Shade the intersection of those 2.
The intersection is from 4 to 7 here, like this.
So come back to the statement. Come back to your work here. So it is very important to always draw that set to help you decide.
Okay, thank you. So we shall have here so we shall start now here from probability of x is equals to 5 plus probability of x is equals to 6.
Okay, Mary Assumpta, kindly check out it was x greater or equal to 4. Yes, but let me, before we continue, check out, still there is something. It was 4, x greater or equal to 4, meaning that 4 was inclusive. But let us first hear from Walim. He wants to add something.
Thank you, Mr. Kaziba. Now, on the number line, I think she needs to draw a full one because from what we have been given, it runs from 1 up to 10. I hope you're getting me. It runs from 1 up to 10, so she would have drawn a number line from 1 up to 10 so that we are able to interpret very well that x greater than 4. So I would request that she goes back to the number line so that we get the correct intersection. Because our greatest value of n is 10. Hello? Did you get me?
Yes, you are clear.
Yeah, from 1 up to 10. Then, as guided before, we are running from 2 up to 7? 2 up to 7. First show that 2 up to 7. Then also show greater than 4. 2 up to 7. We are there, then greater than 4. Greater than 4, we run from 4 up to, but that 4 is inclusive. So draw a small circle there and shade it. 4 is inclusive. Draw a small circle there and shade it at 4. Yeah, we are back to senior 1. You remember number line, eh? Now, you are looking for the intersection. Now, those two lines, if you slide them together, from what number to what number will they intersect? If we push this one downwards, upwards, the intersection will be from what to what? From 4 up to intersection. From, can I hear you?
From 4 to 7.
I think it is now clear. Now, just a small note on that. That is when you are presenting, you reached somewhere that you wanted to talk, but that is what we call conditional probability. They're asking you to find probability of between 2 and 7, given that x is greater than 4. That's the language we use, given that. So you could call the upper part A, capital A. You can even write there, capital A, the upper line. Capital A, uppercase. Then the lower line, capital B. Capital B. Now, I just want you to recall a bit. Just below that, write that P into, just below your number line. P into A given B. A over B is equal to, just recall that, you recall that from class. Over probability of B. So it is that concept that we are using, though it is appearing baluke. So we are looking for that intersection A, intersection B, which is our 4 to 7, but remember 4 is inclusive. Then probability of B. I don't know whether that can help you proceed. Then lastly, earlier on I talked about paper 2. We normally make so many mistakes because paper 2 requires that your eyes must be there, your mind must be there, your ears should be there. But as you are writing that 1 plus 2 plus 3 dot dot, that's supposed to be 3 dots mathematically, dot dot plus n. You said very well that plus n, but check back into your work. Did you write plus n? Just check your steps. Plus n, the first steps. Yeah, someone on the camera, you can focus the initial work if it's not rub. The initial work. Just focus there. No, initial one, where you equate it to 1. We are summing up probabilities equals 1. Let's focus. Oh, you rubbed it off.
It was rubbed.
No, don't repeat it. We don't have enough time. But it was supposed to be plus n, but instead you put dot dot n. So technically, now when we are marking, all the work that comes after that becomes wrong technically. So you need to present your work. It should be consistent from one step to the other. The eyes should see what the brain is thinking, and the hand should write what the brain and the eyes have coordinated. You can proceed. Thank you.
So we are back to our work. The simplified part is here. It is when we go to 7. 4 is inclusive. Our function is here. So here we shall have x equals to 7 plus x is equals to 8 plus 3x is equals to 9 plus x is equals to 10. So from here, our function is here, px. Our p was 1 out of 55. So here we shall have 4 over 55 plus 1 over 11 is the same. 5 out of 55 is the same as 1 over 11 plus 6 over 55 over 4 over 55 plus 1 over 55 plus 6 over 55 plus 7 over 55 plus 8 over 55 plus 9 over 55 plus 10 plus 10 over 55. So we shall add and divide by this. 4 over 55 plus 1 over 11 plus 61 over 55. Here we shall have 6. Let's add again. We shall have 4 over 55 plus 1 over 11 plus 6 over 55. Then we shall have here 3 over 11 divided by 4 over 55 plus 1 over 11 plus 6 over 55 plus 7 over 55 plus 8 over 55 plus 9 over 55 plus 10 over 55. Here we shall have 49 over 55. Then we shall divide this by this to get the probability. We shall have 3 out of 11 divided by this answer, which is 49 out of 55. Then our answer will be 15 over 49. I think this is our last number. Wish you all the best.
Okay,
Any questions?
in case you have, yes? Okay, thank you so much. We are going to do our last. Okay. We are going to do our last. The last question is going to be shared by 2 schools. Stelland College Matuga is going to do part A, and then St. Catherine Lila will do the last part. We are going to do number 56. So Stelland College. Kindly. Then Lila prepare after part A.
Hello, good afternoon. This is Magazine Stelland College Matuga. I am presenting to you number 57, mechanics. It says that 2 particles with masses 6 kilograms and 3 kilograms are connected by a line inextensible string passing over a smooth fixed pulley. So as drawn here, because of time factor, I drew it pattern. They'll say 2 forces 6 kilograms, masses of 6 kilograms and 3 kilograms. But 6 kilogram mass is greater than 3 kilogram mass. That's why I've drawn it like this. These strings must be taut, and if they are taut, we expect to have a tension in the string, which is T. We are putting it T because the string is the same. If the strings were different, we would have used different tensions. And when these masses are moving over a pulley, expect accelerations. We shall have this 6 kilogram mass is pulling, the 3 kilogram mass, that means it is going downwards. And our acceleration will be 8 meters second squared. Even this one is going up because it's being pulled, and we shall have 8 meters per second squared. So let's start our calculations. We are going to start with the 6 kilogram mass, and we shall say for the 6 kilogram mass, our resultant force will equal to what? For the 6 kilogram mass, we are seeing it is going downwards and it is pulling the tension. That means that our resultant force will be 6G minus T. Minus T. And our resultant force in this case is 6A. And we shall have 6A equals to 6G minus T. And we shall denote that to be our equation 1. After that, we have the 3 kilogram mass, and we shall say 3 kilogram mass resultant equals to what? Because in this case of the 6 kilograms, we saw it was pulling T. Then it was 6P minus C. Now this one, T is the one pulling the 3 kilograms. So we are going to say our resultant force is going to be T minus 3, T minus 3G. And the resultant force, as we know, I didn't explain here, the formula is a force equals to mass times acceleration. That's why you're seeing 6 times acceleration, which you don't know. Hope I'm clear. So we are going to have 3A equals to T minus 3G. Now we are looking for acceleration. We are going to add these equations. We are going to say adding equation 1 and 2. We are going to say adding equation 1 and 2. We are going to add them like 6A equals to 6G minus T, then plus 3A I forgot to denote our equation 2. I asked to be forgiven. So we are going to add equation 1 and 2. So it equals to T minus 3G. So if you are adding, we're going to get here 6A plus 3A, we shall have 9A. Now here, 6G plus minus 3G, we shall have 6G minus 3G, which is going to be 3G. Now, negative T plus T, we are going to have a 0. Hope I'm clear. So our A is going to be, we have 9A equals to 3G. Therefore, if we divide by 9, we shall have A equals to 3G over 9. But we know our G is 9.8. Therefore, A equals to 3 times 9.8 over 9. Uh, 3 times 9.8 divided by 9. Therefore, our acceleration is going to be equal to 3.2667 meters per second squared. I've recorded my answer to 4 decimal places as required. I ask to rest my case.
Okay, thank you so much. Let's have St. Catherine. St. Catherine. St. Catherine. Unmute. St. Catherine, SS leader, unmute. Okay. St. Catherine, talk. Be audible, be audible.
Since we are sharing the number with college, and we are at the part B of the question 57, which is saying that to get the tension of the string. So now to get the tension of the string, first in the Roman F, which was run by the college, they got the acceleration equal to 3.267 meters per second square. So now we have the acceleration.
What's happening to St. Catherine? We can't hear here.
Be audible, increase on your volume.
Now we have the value of the acceleration.
Turn on your camera.
Share the camera. Camera is there, you have to.
Now we have the value of the acceleration. We choose any among the equations to get the tension of the string.
No, maybe there.
Since now we have the acceleration, we choose any among the two equations to get the tension of the string. So if we are to choose the second, we can get all the first one. So as per us, we are going to use the second equation. So considering equation Roman 2. This the tension minus 3G is equal to 3A. So T minus T minus 3 times 9.8, because the acceleration is gravity, it's 9.8. It's equal to 3 times 3.267.
Okay.
So if we multiply 3 times 9.8, it's 29.4. It's equal to, multiply 3 times 3.2667, we get 9.8001. So we take this one, this side to get the value of the tension. So T minus 29.4 is equal to 9.8001. T is equal to 9.8001 plus 29.4. Giving us 39.2001. So part C, it's saying that we get the force on the pool. Saying that you get the force on the pool. So if this is our pool, we need to get the force, but the force is acting from the center upward. So they're saying that we get the force that's acting on the pool, which is the R.
So now, since the pulley is not moving, so our acceleration is 0 meters per second squared. So it implies that R is equal to T plus T. It's implying that the force that is acting up is equal to the force down. So now R is equal to 2T. But we have the value of T, so we substitute the value of T in here together. Force. So R is equal to 2 times 39.2001. Our R is 78.4002.
Thank you so much, Lila St. Catherine SS Lila, for the wonderful presentation. I want to just share my screen just for a minute to make some clarification on one of the numbers, because it seems some schools are really not getting it. When you look at what we had, this is our number line. And one number line, you can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Now, when you look at our number line, we are given a condition probability. And our condition probability was that probability of 2 less than x less than 7, given x greater or equal to 4. When I look at only probability of 2 less than x less than 7, remember, by definition, when you are defining a condition probability, that probability of A occurring given that B has already occurred, we know by definition, this is the same as probability of A intersection B out of probability of B. So still here we do the same. It means that we shall have probability of 2 less than x less than 7 intersection probability of x greater or equal to 4 out of probability of x greater or equal to 4. So if I can first deal with this part here, this first probability here, and I want to show 2 less than x less than 7, it means that when I go to my number line, I'm going to show 2, I'll use an open circle. Because 2 is not inclusive, then I'll draw my line up to I have 7, up to this point here. Because 7 is not inclusive, so I'll draw an open circle. Remember, when we are dealing with inequalities, we say that whenever your circle is open, it shows that this number below is not part of your solution. This number 7 is not part because they are not inclusive. When I go to the second one, I have x greater or equal to 4. When you look at greater or equal to 4, it means that in our set, we shall have all numbers starting with 4, 5, 6, and so on. All those numbers that are greater or equal to 4, meaning that 4 is inclusive, is part of our solution. So when I'm on my number line, I can draw it down or I can draw it up here. So when I draw it down here, I'll have my circle. But since 4 is inclusive, and in order for us to show that 4 is part of the solution, then I'll shade, or I'll use a shaded circle. Now I'll shade my circle to show that now 4 is inclusive. But where am I going to have it? Since it is greater than 4, I'll draw my arrow going this side. So that is my arrow. Then I'm going to look out for the intersection of these two lines. So when I come here, I'm seeing that, let me use another color. Let me use this. When I come here, you are not seeing that when I draw a line like this, these two lines intersect, or in fact, or when you move it, you are not seeing that these two lines are going to intersect like that. So when you look at the blue line and this green line, you are not seeing that they are intersecting from this point here up to here. But at this point, 4 is inclusive, meaning that we shall have probability of 4 less or equal to x. But at this point, much as they're intersecting, the blue line and the green line are intersecting, but 7 is not inclusive. So is not part of the solution. So meaning that we shall have less than 7. Now, when you look at your number line, the numbers that are within that intersection part, you have this 4, you have the 5, you have the 6, but 7 is not among, meaning that the probability we are going to take, we shall have probability of x equals to 4 plus the probability of x equals to 5 plus the probability of x is equal to 6. So we shall not have 7 because 7 is not inclusive. Alternatively, in case you do it in the other format, we have 2 less than x less than 7. If at all you are to show like maybe numbers between 2 and 7, it means you integers. It means you mention numbers like 3, you'll mention numbers 4, you'll mention 5, you'll mention numbers like 6. In case you are showing numbers, let me say numbers that are greater or equal to 4, it means that in your set, you'll have numbers 4, you'll have 5, you'll have 6, you'll have 7, and so on, something like that. So when you look at these two sets, what the intersection, that means those numbers that are common. You have 4 here, you have 4 here. You have 5, you have 5. You have 6, you have 6. So that means that in your intersections, you have 4, you have 5, and you have 6. So those are the numbers that you are going to take on. So that's why for our probability, we took on the probability when x is equal to 4, when x is equal to 5, and when x is equal to 6. So that's how we can approach that number. So in case you have, and please let's distinguish it from when you have 2 less or equal to x, less or equal to 7. In case our probability was like that, that means that in your set or on your number line, then it means that you'd have shaded the 2. But since it's not part of the intersection, then still it will not be relevant. Okay, thank you so much. Okay, now that is where we are stopping with our discussion today. Lira SS, we are not going to have any further discussion, but I'm going to ask the teacher to record or to stay online and we record that presentation because we want to release students to go for lunch. So teacher, I'm going to ask St. Catherine to stay online. I'm going to ask also, in case your school there's a number they have not presented, I'm going to ask you, you're going to stay online and then we shall record the numbers. I want to, this is where we are going to end with our discussion, but before we end, I want to ask HOD, I'm going to ask 2 teachers to have their last package for the candidates. I'm going to ask the teacher from Matuga College in 1 or 2 minutes. I'm going to ask Mr. Nabohe to have concluding remarks. And then after I will invite Mr. Rand. Yes, City College. Mr. Nabohe, prepare. Okay. Stelland College.
Yes. Good afternoon. We are so glad to have this wonderful presentation once again. I want to talk to candidates countrywide. There's always a tendency of candidate thinking that you can do paper 2 without the mechanics please don't be deceived. You have to cover everything as you see in the guideline. The table of contents. You have to cover everything on papers. Now, looking at the number the student attended in here, we are dealing with connected bodies. Emphasis goes on the number of streams that are applied. If you find that it's not one stream, be careful about retention. And then also when you find that there are more than one, still take care of that. But I encourage you, wherever you are, take paper 2 mechanics seriously, and especially those candidates who don't do physics, they find it hard. But I encourage you to take it up so that you can have all the numbers in paper 2. I wish you all the best and success wherever you are. I remain teacher Odeke Daniel from Switzerland College, Matuga. Thank you so much.
Oh, thank you so much, Matuga. Let me have Mwalimu. Mwalimu.
Thank you. Yeah, thank you, Mr. Kaziva and your team. Yeah, allow me to take this opportunity to thank Helpline Learning Platform for organizing this seminar. At the same time, in a special way, I would like to thank BLSS Global Administration, led by the head teacher, Mr. Viera Moses, for enabling us to participate in this virtual seminar, which is countrywide. As I said earlier on, it's costly organizing such seminars, but BLSS administration since the inception of Help Learning Platform, the head teacher with his administration, they have always supported us. Secondly, I want to thank my colleagues in the Department of Mathematics for taking their time to prepare students, to prepare resources, to sacrifice their time up to this level where we have participated. The ICT team in BLSS is led by Mr. Masabe Elisa. At a later time, I think we'll allow him make some comments because I'm sure he's also part of your national team. I just want to make a few comments as far as passing mathematics is concerned, because all this, at the end of it, we're interested in making our candidates excel. I'd already made some comments, but you allow me make some here again. That when it comes to pure mathematics, it is the center of mathematics actually, but students overrush. They are too speedy, and I've observed over years that a student may be a very good mathematician, but because of speed, they end up making very many mistakes. And it costs them, they know the concepts, but they misuse the concept. So I'm asking or calling upon them that they should not be too fast, neither should they be too slow. They should be moderate. In that way, they will avoid making very many mistakes along the way. Then my interest is paper 2. When it comes to paper 2, of course, paper 2 also uses the pure mathematics in order for you to excel. But again, that very rushed approach, if it is brought to paper 2, it is the worst. Paper 2, as my colleague observed, and I think some other person in the chat, normally the questions are extended questions. The questions are lengthy. They are full of words. They are full of terminologies, language terminologies. So a candidate must take time to read and read. After reading, interpret the question. After interpreting the question, should summarize, because these are sentences in words. Then one can make summaries. say in mechanics, if a question is on motion in a straight line, you can summarize which one is your initial velocity, which one is the final, which one is acceleration, what do they need to find, what is there, but it is indirectly implied. Maybe they have said the particle reached maximum height. The question is, so what if it reached maximum height? A candidate must take time to think of that so that he or she can easily now realize that the final velocity is 0. Otherwise, in the question, it is open. You can't see that is 0, but it has been given. And if it is vertical motion, again, there's some other value given, but you can't see it unless you take time to think through or use your experience, like acceleration due to gravity. It will not be given in the question, but it is there. So such questions, we need to take time. Questions on probability, the language matters a lot. So candidates or students need to take time to practice, reason out, share, discuss, make consultations with teachers and their colleagues here and there. Make use of online platforms. There are now very many. They can search for knowledge, skills from there. Then the other issue is, again, when we are answering questions as candidates or students, I have observed that if you are rushing, sometimes even what you are seeing, it is 12,000, but you may end up writing it as 1,200 and you will not know it. Just as I commented earlier on, the other candidate or student who was discussing a number on discrete random variable, she said plus n, but the plus was not there. And she was looking at it. Yes, the eyes are there, she's talking, but the two are not assembled together, they are not working together. So we need to assemble our eyes, our minds. After reasoning out, the hand can write the correct step, so that from step to the other step, our work is consistent. And the other issue you'll allow me comment on is the calculator. Now, calculator, I think, is part of ICT now. Unfortunately, when it comes to A level, we begin using a calculator extensively. But again, I've observed, I think we don't take time to teach students how to use this calculator, which is almost a mini computer. I think it is upon us, again, teachers, that as students come to senior 5, let's take them through calculator use. Then after that, progressively, they can improve. A calculator can be a good source of making marks, but at the same time losing marks when it comes to degree of accuracy. By UNEB standard, if the degree of accuracy is not mentioned, candidates are advised at least to put their answers to 4 DPs. This is in line with mathematical tables. In case a calculator is used and it presupposes the answers are not exact. So at least 4 decimal places. It is UNEB now to decide whether to mark up to 1 or up to 4, but 4 you'll be in a safe zone. Then when it comes to trigonometrical functions, this is where there's another source. There are questions that require us to put our calculator in radians, especially questions that involve trigonometrical functions like sine, tan, cos, and that is common with the trapezium rule and in pure math also. So when the question doesn't require, or the values are not in degrees, automatically our calculator, if we are to use it, it must be in radians. So candidates should take note from time to time to check, is my calculator in radians or it is in degrees? The question I'm presented with it, is it in, does it require me to convert the mode to degrees or radians? If number 1 is a question maybe on mechanics, that a body is resting on an inclined plane at 30 degrees to the horizontal. So it is already measured at 30 degrees to the horizontal. So when I'm using my calculator, it should be in deg. Now, when I go to number 4, maybe it is a question on trapezium rule and are saying integrating from 0 up to say pi, of course, say x dx at this point. If I don't recall that my calculator in number 1 was in deg, and I must now go to degrees, to radians, I will do that number, the steps will be okay, but the answers will be wrong. So as teachers, we should continuously remind our students to be keen about that. You have observed, like in my school, in most cases, you find the results come back. Students have performed very well paper 1, but paper 2 is poor. Someone has a D1 in paper 1, maybe a credit 5 in paper 2. But we are trying our level best to see that there's positive correlation in performance between paper 1 and paper 2. And the last year results, we managed at least to have a correlation in that, but it is a struggle which we must see, carry on, and I believe other schools may be also finding the same challenge. Then last but not least, Mr. Kaziva and the rest, mechanics, this area is still, many schools, many students find it a little bit unbecoming, because there's no mechanics question you do without putting there too much thinking. So again, we should encourage students right away from senior 5 to get involved in all areas or sections of paper 2. And when we are teaching mechanics, let's begin by presenting simple concepts first and illustrate them from real life experiences. Like last time we had that workshop, which was, I think, in Guru, St. Joseph's, and how Mr. Izito Chite, or the head teacher of that school, demonstrated. If we can have those simple practical examples from which students can now see and try to understand what we are talking about. So when it comes to tension in a force, again, students normally confuse this. They don't know which direction they should show, but we should demonstrate that, maybe using a pendulum bob or another thing or string in the lab. If you hold it like a pendulum bob with a string and you let it, it will go down. And when you ask students, they tell you it is due to gravitational force. But if you are holding it, again, you ask students, why is it not now falling? At least they will be able to say the hand is holding it or you are holding it. So that force must be acting upward. So when they are drawing the tension at the point of attachment, tension must always act away. At the point of attachment, tension must act away. Down, it is attachment, it acts upward. Then again, upward, it is attachment, it must act downward. We must be able to demonstrate that. It's a very common mistake when you check through students' scripts. Then the other thing is that when we are drawing diagrams of involving forces, UNEB requires that we use a straight edge, a ruler. Students should not draw force diagrams with free hand. Those lines must be straight with arrows indicating the direction. That is where the first marks go. And if your diagram is wrong, definitely the other steps will not, most likely will not be correct. So I think that is what I would say per now, but I would wish that I now have taken some minutes, but you allow Mr. Masaba to add 1 or 2 things. He has been at the center of everything this for almost a week of a week. Thank you, Mr. Kaziba, for giving me this time.
Thank you so much, Mwalimu Fred, for those remarks. Teacher Elisa.
All right, thank you so much, Mr. Kaziba. I don't know if I'm audible.
Very audible.
All right. I'll start by appreciating the schools for turning up, and Baleses in particular. I want to thank the students who have been participating in this since we started this early last week. Mr. Kaziva, I wanted to tell you that we had about 90 presenters in this seminar, like Mr. Nambo has said, but somehow because of the many schools, we wouldn't bring all the participants here, the presenters here. I want to thank the Holistic Learning Platform for at least giving Baleses a chance to present. Like Mr. Nambo has said, we have been on ground and the students are very excited to have participated in this virtual seminar. And they are very happy to see above all the schools that have been participating here. It has been a very good learning curve for them. And I pray that maybe we organize this one more time. The only advice I can give my candidates and the candidates out there is that we need to stick to the timetables that the schools give, and also use the same timetables to draw your personal timetables. Otherwise, if you don't have a personal timetable that you use, somehow you may not find time. Like if I'm to borrow a leaf from Bali Secondary School here, we engage our students from 7:30, 6:50 to 6 in the evening. So you may not find the time if you don't develop your personal timetable. And I want to encourage them to group discussions, especially in math. We were trying out here numbers from the other week, and I realized that students become too constructive if put in smaller groups. So I want to encourage that spirit, especially to my presenters here and the presenters out there. Let's take up this collaboration, and somehow it can convert your marks that you were to get to even a better mark that you can get when the national paper comes. I want to thank my team that is led by the head of department, then the whole administration, for making it again for Baleses to participate in this virtual seminar. I've been working so hard with one of my colleagues, Teacher Putan. Also want to recognize his efforts. Maybe Mr. Kaziva will have to hear a word or two from Teacher Putan. Thereafter, I would suggest that you take back the microphone to the plenary. Teacher Putan, you're most welcome.
Thank you. Yes, good afternoon, everybody. I'm Nicholas Putan, and I am very pleased to be part of this great activity of integrating mathematics with ICT. From the start, I've always been interested in this thing, and I would like to appreciate Mr. Dungu, Mr. Kazive, and the whole help team for this great opportunity and always given to us. Yeah, I just want to encourage learners to keep on practicing. There is a way this help program is giving confidence to our learners. Like last year, the outcomes were really seen. All the learners who participated, they really, at the end of it in UNEB, the results were good. So I ask help to continue with this program and encourage learners to continue practicing. Where there are very many questions that they organized, but we managed to go through a few of them. So I call on learners to keep on practicing throughout the rest of the other questions. Otherwise, I don't have much to say. I will only say thank you, everybody who has enabled this program to go on. Thank you very much.
Thank you so much, Mbale SS. We are going to have more two people. Timothy, are you still on? Timothy from Reno. Yes.
Yes.
Okay, give us your word, the way you have seen the seminar.
All right, thank you, Stephen. On our part, we are grateful again as Reno that we're in position to have to see that there's I was here having a discussion with Mr. Dongo, and he was excited to see that the presentation from Ajumani was being heard by someone in Matuga and all that. And for us, we attribute all this to the work that Ren is doing with the collaboration. Again, we also want to thank all the participating institutions. I think this has been a very great thing. And as Ren would really want to say that next time when some activities like this are organized, we want to be at the forefront to see that we have a bit of input on it as well. We thank you, Stephen, for chairing the whole session and all participating students. And again, I want to say again, thank you to Mr. Dungu, honestly, for making this all happen and seeing that Ren also plays a big part in it. I thank you all and have a great weekend.
Okay, thank you so much. I want also to take this opportunity to thank all the schools that have participated in this session. Thank you so much. I want to thank the teachers that have been supporting the children to see that they attend this session. We are also really very grateful to the teachers, dear students. Let's join our hands to clap for our teachers who have been with us from 9 a.m. up to this time. Thank you so much. I want to thank in a special way Research Network of Uganda, RENU, for boosting the school's internet. All schools that we on RENU have been boosted. We are really very grateful. Dear Timothy, please take our appreciations. And also we want to thank all the teachers who have been behind the camera. I know there have been ICT teachers behind the camera. We are really very grateful. Thank you so much. I want also to thank Mr. Mawanda. Thank you so much. We have been together since yesterday up to now. Ms. Mwalimu Nabohe, thank you so much. I want also to thank all the teachers and all the students for joining. This is just the start. We shall support you up to when you sit for your final exams. Like you have noticed, we have not been able to complete all the questions, but we want to promise that after your mock exams, we shall still have such a session to meet and discuss all the mock papers that have been done by all schools across the country. We shall meet and have our finals. We shall at least have module seminars such that you are really well equipped. Maybe even we shall separate and say this time we shall have only paper 1, this time we shall only have paper 2, such that we can be able to complete everything. We are also going to have a joint exam that will be done by all schools across the country. We shall be sharing that exams with other schools such that we can share the same cake and we see our stand compared to all what is happening in other schools. We want to apologize to the schools that have not been able to present. I know many schools that presented very many presentations, but the time couldn't allow us to have all the presentations played. So we want to apologize, but we want to ask the teachers to record all those presentations. Use your phone, use the computer, have those presentations recorded, send them to us, and then we are going to integrate them into the final video that we are going to be sharing with the rest of the schools across the country. We want to thank you so much. And at this point, allow me to invite Mr. Ronald Dungu to give us his concluding remarks. But also I want to, in a special way, to thank Mr. Ronald Dungu and the whole team from the Ministry of Education for giving us this chance. Thank you so much.
Thank you, Mr. Kaziba. May I request all the schools to turn on their videos if possible? Mr. Kaziba, can you allow them to turn on their videos?
Okay.
Turn on your videos. We want to see you where you are. Don't worry. Whoever can, all the schools turn on your videos. And Mr. Kaziba, please take the picture. Please take the picture.
I'll also ask Renew to turn on their video so that we have the picture of the Renew logo in the background. So please, Mr. Kaziva, make sure you take the picture. I'm also going to take one here. So dear teachers and students, I want to say that we appreciate the effort put in, and we want to thank the organizers of this event, Holistic E-Learning Platform, partners, Renew, UICT, for making this possible. It's been worthwhile for us to be here up to this long. I want to thank the head teachers and the teachers who have allowed you to attend. I'm sure all of us learned something out of COVID. And one thing I learned on my part is that we need to use technology in our education. If we don't employ technology, we shall be found wanting at some point. But also we need to close the learning gap so that whoever knows something can teach the rest of us how to do what they know. As Ministry of Education, we are committed to transforming the education system in Uganda. It is therefore an exciting moment for us to see that some schools can test the possibility of closing the learning gap through the use of technology. I'm sure there are quite a number of initiatives taking place on the level of head teachers, but now we have students learning together, and that is very critical. You are candidates, and what we expect out of this is good performance. So take down all the questions, work out the questions. Let's have another seminar where paper 2 is well represented so that we all excel. If all of you who are here that I'm seeing in this picture can excel and give us an A or a B, at the worst a C, then it means that we are having either more people lined up for engineering, more people lined up for medicine, but also probably more people lined up for computer courses. And the development of this country will definitely be on the higher side. So I'm hoping that you're going to do your best going forward and make sure that you complete all the questions you've done. With that, I want to wish all of you the best until when we meet again in another seminar. And I want to say that this seminar is now closed. Thank you for listening, and God bless all of you.
Amen. Thank you so much. Mbale SS lead us in a closing prayer, and we leave this session. Mr. Masaba, a prayer from Mbale SS, and you pray for everyone, and you such that we can attain success in our mock exam.
I want to take this opportunity to thank all the organizers of this session because it has done us well, especially as the candidates. Before I go into a prayer, I'm going to bless everybody wherever you are. The Lord we serve is omniscient God. He's everywhere, omnipresent, He's everywhere. So just humble yourself wherever you are, and you can close our eyes, or in a way you can humble yourself. Let's believe and pray. Dear loving Father, the creator of heaven and earth, I want to take this opportunity to thank you for a gift of life. I want to take this opportunity to thank you for the great men and women who have made this meeting to pass today, so that we are together, Lord, in the union, Lord. We are together spiritually. We are together, Lord, through the technology, through the wisdom you gave to the white people to bring in technology. Lord, we thank you for this wonderful thing which is happening in Uganda. We have just been watching it on television. Lord, we thank you that there is an advancement in our technology. Thank you, Lord, for the progress.
Thank you, dear Almighty God. Lord, at this hour, dedicate every school wherever it is. Let your hand to touch on every school wherever it is, from the head teacher to up to the students, Lord. Raise them in different ways. Raise them spiritually. Raise them in the mind. Raise them, Lord, in knowing your word and serving you. Lord, I want to put our school, but school into your hands, Lord. We put all our things down, Lord, to worship and to glorify your name. Lord, whatever we do, we call upon your hand to be in. Whatever we do, Lord, lead. Lord, I pray for the organizers, the rainy camp. Lord, I pray that you continue giving them the wisdom as you did it to King Solomon. Lord, give them wisdom to continue finding in the easier ways of modifying the thing so that Ghana can be viral, my Father. Lord, I want to dedicate all the other village schools which are not yet in this thing, Lord, because of the problem of poor network in some places, Lord. Lord, just to bring in the spirit of development, wherever there is the hindrance of the devil from the work we're developing other places. We know there's some altars, Lord, which are not good, which are prohibiting development. Lord, welcome you to intervene, Lord. Come and bring in the development so that the next time when we meet, we be more than what we have been today, so that we can double the number we have. We thank you, Lord. Bless every candidate. Touch on every candidate in his work ready. Give them the spirit of wisdom and understanding. Bless the teachers. Bless the administrators, Lord. Thank you, Lord. Thank you, Jehovah. Pray all that expecting much from your Lord Jesus Christ. We have prayed and believed.
Amen. Thank you so much. I'm going to ask teachers, kindly take some photos for your students that have attended the seminar. Take a photo of that room and then share with us. I'm dropping the number. You can share those photos, and then we shall be able to share with the minister and other people. Kindly share and bye-bye. Kindly unmute and you tell us bye-bye.
Bye-bye.
Okay.